Let me share my screen and we'll get started here. All right, so if you're seeing my screen, you see a line segment there on the left. We need the two endpoints of this graph. All right, so the two endpoints here, the one on the left here is -5, -2. The one on the right is 5, 3, like that. Now, do you remember the midpoint formula?
No.
Okay, so you add the x values, x1 plus x2. It really just means to add the x values, and then you add the y values, y1 plus y2, and divide by 2.
Okay.
So if you need to, and it's not a bad strategy, you can actually label the points x1, y1, x2, y2.
Okay.
So it looks like this: -5 plus 5 divided by 2, -2 plus 3 divided by 2, like that. And then you add the numerators first, the numbers in the numerator. So in the one on the left here, it's going to be 0/2. The one on the right is 1/2. 0 divided by 2 does reduce to just 0. So there's your midpoint for that first one. Sometimes it's good to label it on the graph just to kind of confirm that that actually is the midpoint. Kind of looks like it visually. I would probably agree that it does.
Yeah.
So we actually use the midpoint in our daily lives. I mean, if you want to meet a friend somewhere and you don't want to drive all the way across town where they are, you often meet in the middle. And that's what we're doing here. We're just determining where is the middle between these two particular points. All right, so could you tell me the left endpoint here? This, I've kind of trying to label it letter A here. Can you tell me the coordinates of letter A?
It's -1, 2.
Correct. And then let's try for letter B. What's the coordinates of that?
0, 4.
So 4, perfect. So I think it's good to write the midpoint formula each time you use it to remember it, unless you get a formula sheet on a test or quiz. You know, it's just one of those things you gotta maybe commit to memory for this. So if you need to, label the points x1, y1, x2, y2. So we've got like -1 plus 0/2, and then 2 plus 4 divided by 2. So on the left, it's -1/2. On the right, it's 6/2. And then you can reduce if possible. Any questions on that?
No.
Okay. We can do 3 and 4. I have no problem doing that. It's up to you, or we can move on to like 5, 6, 7, and 8. What would you like to do?
Can we move on to 5, 6, 7, and 8?
Yes. So these already give you the points. In some ways, these are easier because you already have your x1, your y1, your x2, and your y2. So you just have to label the points for clarity. If you do this often enough, you'll say, oh yeah, I got it now. I don't need to write them down. But until that point in time, you're going to add up the X's, you're going to add up the Y's, and you're going to divide by 2. You're basically finding the average of each of those.
Mm,
So it's 1.4 plus 3.56 divided by 2. 4 plus minus 1.5 divided by 2. So I'm assuming you're allowed to use a calculator in this class.
mhm.
All right, so when you're putting this calculator, make sure you add up the numerator first. And if you're not sure how to do that, you put parentheses around it before you divide by 2. Do you have a calculator handy to try out the calculation?
I have the one on my computer.
Okay. So it's not super important that you do it then, because we want you to replicate whatever you'll do on a test or quiz. But just keep in mind, maybe grab a calculator next time we meet, or have it handy. But the other one is 1.25. So really not difficult. It does take some time to do the calculations, but you're just moving these numbers into the formula. Nothing more than that. Right, so let's so why don't you look at 6, 7, and 8? Which one we can do? We should do one more of these. Which one do you want us to do?
Mm, number 6.
Okay. Let me snip in number 6. All right, so I would recommend labeling them X1, Y1, X2, and Y2. So our formula here is X1 plus X2 over 2, Y1 plus Y2 over 2, like this. So we got 7.2 plus negative 11.899, all divided by 2, comma, minus 9.9 plus 11 divided by 2. Okay, so let me grab a calculator here and determine this value. So this one is minus 2.3495. And then the other one's a little nicer. It's 0.55. Any questions on that?
No.
Do you feel like you can do 7 and 8 on your own? Or do you want us to do them?
Can we do them?
Yes. This time is completely at your discretion. I'm only asking just because I want to cover as much as we can, but you are the customer. You get to decide. Okay, so just like the previous problem, you want to label the ordered pairs X1, Y1, X2, and Y2. And you do it until you don't need to do it anymore. It's like you might have sang a song to tie your shoe at some point in your life, but I doubt you do that now when you tie your shoe.
Yeah.
But whatever you do have to memorize this formula on the right. by writing it each time, I feel like that could really help anyone figure it out. And then all we're doing is just substituting those numbers, and we're always combining the first two numbers and then the second number. So minus 3.3 plus 9.4 divided by 2, minus 6.8 minus 7.3 divided by 2, like that. And grab a calculator. So that's 3.05. And then the one on the right here is minus 7.05. All right, next one here. It's like the assignment got more difficult the further we go down. The next grouping of problems are more difficult than the previous ones because of the numbers they've chosen. Okay, number 8 here. So we got x1, y1, x2, and y2. Write the formula again. And then you just pair up the x's and pair up the y's. So we got 2.5 minus 3.6 over 2, minus 8.5 plus 10.8 divided by 2, like that. And I'll grab a calculator here. And like that. So minus 0.55, comma, at 1.15. Let me know when we can move on to number 9.
Yeah, we can move on.
Okay. All right, so here's number 9. This time we cannot just use the formula. They give you an endpoint and they give you a midpoint, and they really want the other endpoint. Did you see any of these in class recently?
No.
No. Okay. So here's what I'm going to do here. I'm going to actually graph this point for us. And then I'm going to graph the other point because the visual representation of it, I think, is very important here. I feel like it's a lot easier to learn something by seeing where it is on the graph. So let me that's not so good. Let me just, okay, here we go. All right, so here's a picture of what we've got. So this first coordinate here is an endpoint, and this other coordinate is the midpoint. So I think you can roughly see that the other endpoint is somewhere over to the right here. I'm sorry, to the left. Would you agree with that?
Yeah.
Like you have to be careful that you don't try to put the other point up here on the top right. So you don't need to be this exact with your graph. You could just make a quick hand sketch and be like, yeah, that first point's about there and the other point's about there, and then the last one's there. But that does help you. So I call this, let me just reframe the question here. Let me grab this again. I like to use the terminology of a jump. So if you go back to the picture, there's a jump from the endpoint to the midpoint. Like imagine you're a kid, really young, you used to jump from, station to station or something. So we want to figure out the jump from the endpoint to the midpoint. Now, this one's a little bit harder because we don't know what it is. It's not like obvious to us, but we can make an equation for it. It's negative 1/3 plus the jump, which I'll call x, equals -5. And I don't know why your instructor chose such challenging numbers, but you know, normally these are nice numbers in these types of problems, but they're not for you. So to do this, to take -5 and add 1/3 to it, you have to make a common denominator.
Mhm.
So you're gonna change the -5. You're gonna multiply the top and bottom by 3. So it's -15/3 plus 1/3 -14/3. So your jump, and your jump can be negative, is -14/3. Like that's literally what you add to it. Even though it's negative, you're adding to it. So to find the other endpoint, you make the same jump. You need to add -14/3. So you take that x value and you add the -14/3 to get there. And I know that's not exciting, but that is the step. I mean, you have to figure out what it is to get from the endpoint to the midpoint, and then the midpoint to the next one, to the other endpoint. So again, you have to add, unlike denominators, you have to make them the same. So you multiply top and bottom by 3. So it's -15/3 plus -14/3 is -29/3. So that's your other endpoint. But that's just the x value. So now you similarly have to figure out the jump from this number, 3 5/6, to -1/5. And I mean, again, like, I just don't know why these numbers are so complicated, but that's what they did here. So it's 3 5/6 plus x gets you to, what did I say? What was that number? -1/5. So on the left here, you have to convert this from a mixed fraction to an improper fraction. So you take that 6 times the 3 and add the 5, that's 23/6. And then you subtract that from both sides of the equation. So again, you got to make a common denominator. So it's going to be 30 this time. So that's multiplying the top and bottom by 6, so -6. On the right, you multiply by 5. And you have 115. I cannot believe these numbers. I mean, it's incredible. So it's -121/30. So that is your jump. Like you add -121/30. And so you have to do that again with this other one. You have to add -121/30 to the -1/5. Okay, so we'll do that down here. -1/5 plus -121/30. Multiply the top and bottom by 6. -6/30 plus -121/30 -127/30. So that is your other value. That's your other endpoint there. Now, I don't like these numbers. I think, I mean, we're really working hard here to do these, but that is the process here. We can keep going and do the rest of them. We can also move on to another topic if you would like. It will take some time to do the other ones, and I'd like to find out more. Is this just for homework, or is it for a grade, or is it for just like how important is it that you get these correct and done?
Not too important.
Okay, because these are like, I would give these to an honors geometry student, not I think we're limiting our returns on our time here. So if you're willing, I'd like to move on to another topic.
Can we do the 3.1 vertical angles?
Yes.
Well-
3.1. Show yourself. Oh, and there's a backside to that. Okay. So I missed that. Yeah, I mean, there's a backside to it as well. It's just as bad. All right, 3.1, 3.1, 3.1. I don't see 3.1. Okay, let me check here.
I can send another picture.
Nope, I found it. It just, they upload in a different order. This is the name, the relationship one.
Yeah.
Okay. Yeah, this will be pretty quick. I thought we worked on this time before. Maybe not. Maybe it was just related to this.
Yeah.
All right, come on. Here we go. Technology issue. There it is. Okay, this looks like problem one. Is that correct?
Mm-hmm.
Okay, so yes, these are vertical angles. And I don't think it needs any more information than that. But you might say that the measure of angle A is congruent to the measure of angle B. I'm sorry, they're equal. Or you can just say that the angles are congruent. You could say that angle A is congruent to angle B. I think that's all it's asking for.
Okay.
So in geometry, generally you have things that are equal or things that add up to something. These are equal because they're vertical angles.
Mm-hmm. So would it just be the same for both of them, for 1 and 2?
Yeah, so I'm going to snip in number 2. Sorry, I'm a little slow on that. But yeah, it's actually the same information. Yes, vertical. And I would just say that angle A is congruent to angle B.
Okay. And 3 and 4.
They're correct. Sorry to
Okay.
interrupt you, but they wanted to just tell you they're fine.
Mm-hmm.
Star, check mark, whatever you like on those. All right, now for 5 and 6, a bit more work to do. We'll do number 5 first.
Okay.
All right, so number 5 here, these are vertical angles, and vertical angles are congruent. You don't have to write this, but you want to like have a mental like recording of vertical angles are congruent, which means they're equal. So you set them equal to each other. And then you solve for x. So to do that, you subtract 3 from both sides, and you get 84 equals 6x. And then you divide by 6. So x equals 12. I think it just wants the x value. Yeah. Sometimes you have to put that value back into the equation, but here it just said to solve for x.
Okay.
So let's try number 6. All right, so number 6, again, their vertical angles are congruent, so you set them equal. And if you're ever like unsure on a test or quiz, like what to do, you can just set them equal or add up to something, you know, pretty good chance of getting it right. Do you mind trying to solve this one for us? Give this one a try.
Is it 18?
Yes, X is 18. Perfect. All right, just give me 30 seconds here and I'll be right back with you.
Okay.
All right, so so is that everything on that page? Yeah. Now, is there a backside to the vertical angles?
Um,
I'm not seeing it if there is.
no,
Okay.
there is the the 2.5 construction
Yes.
how is it?
Construct the perpendicular bisector of each.
Yeah.
Do you have a compass?
Oh no. I remember I did this before, but
You
I
don't
lost.
you don't need it. I mean, we can sort of fake it. But yeah, I mean, nobody, it's not a useful skill, but yeah, we can move to that.
Mhm.
All right, so the way you do this, if you had a compass, is you would, and I'll do it in a different color here so that differentiate, is you would just go right here and you would measure two arcs that are equidistant apart. So you'd create an arc like that and an arc like that.
Mhm.
And then you would reset the compass into the middle point there, and you would arc up here and arc up here,
Mhm.
and then that would create another point, and then you could connect them with a ruler, and there's your bisector. So the idea is that's 90 degrees. So if you do everything in red that I showed you, it should
Mhm.
be accepted for credit. They've been doing constructions for, I don't know, forever. Like I did them and I didn't think they were useful. I'm sure if it's like, why are we doing this? But they used to be important, really, but
Mhm.
there weren't computers and there weren't, ways to do this other. So it's like painting a picture in the park. You could just snap a photo now, but some people like to paint pictures.
Yeah.
This is the artistic side of math, if you will. Okay, so let me know when I can move on to question 2.
Yeah.
Okay. Okay, so let's do it again. Let me use a different color this time. So again, like in blue, and you would create these two arcs. And then you go to each arc and you would actually swing another arc up here and up here. And wherever they intersect, that's you draw a line through there and get a essentially the same thing. They're just doing different directions on the lines.
Mhm. Okay.
All right, so you ready to move on to number 3?
Yeah.
All right. The thing about number 3 here is they're giving you a triangle, but you actually don't need, like, you don't need the triangle to do this. It's like your focus is just on AB because that's the thing that you care about. So you again, you just pick a point. It doesn't really matter which point you pick, just pick a point. And I would, if we were doing this side by side, or I could even talk you through it, you would stick the sharp end at that point and you swing an arc left of it and right of it. And this is not drawn really all that well, but they're supposed to be the exact same length. I mean, it's close enough. So then you go to each of those places where it intersects, you stick the sharp end in, and you make the protractor, it's a protractor, you make it a little bigger. So that is, and then you swing a bigger arc, and then you go to the other one, you swing it that same arc, and you get a something like that, and then you draw the line through the 2 points. Be better to use a ruler, but that makes a 90-degree angle like that.
Okay.
Now I'm sort of, since we're there is a little bit more to doing this with a perpendicular to make it a bisector, a full bisector. But
Mm.
I guess I don't know how much of that is important, but I'll show you that for the next one.
Okay.
And I mean, because we don't even have a compass or a protractor, so it's like kind of hard to to do exactly, but
Yeah.
okay. So this one is for AB. So you first would actually determine the midpoint. And to do that, you would stick the sharp end in B, and you would create this kind of long arc like that. And then you would stick the sharp end in A, and you would similarly create a thing like that. And then wherever this hits on the line there, that's the midpoint. Now that's not quite to scale. So I can cheat here with technology. I don't know, maybe there-ish. But the point, what you're trying to figure out is the midpoint. So once you get the midpoint, it's exactly like we just talked about. I'll switch colors here for that. You swing an arc from the midpoint, you swing another arc, then you go to the intersection point and you swing yet another arc, and then another arc like that, and then you draw the intersection like this. If that's not easy to see, I can switch colors.
Mm. Okay.
You're probably not going to be ever asked to do this again. Definitely not in math class. I mean, maybe if you want to impress a friend or something someday, but
Uh-huh.
let me know if you need to just step away. We can just pause for a moment.
Oh no, it's okay.
All right. Okay, so that gets us through those. Do we need to go on to 5?
Yeah.
Or do you want to switch to a different topic?
Mm, can we still keep well Can we finish this page? Do you think we'll have time to finish this?
Yeah, I'll do my best. I just want to make sure you get everything out of this lesson that you want.
Yeah.
All right. All right, so number 5, it says to find the circumcenter. Is that right?
Yeah.
Okay. And I actually have no idea what that is, so I'm going to go look because I don't remember. It is the point where the perpendicular bisectors of the sides intersect. So there are 3 perpendicular bisectors that you have to find. And that's the hard part. You just like you basically doing 3 of the previous problems. So let me again, like, let's just pretend like we found the midpoint of each of them, because that really is the first step. Let's just pretend those are the midpoints, but you have to find the midpoints of each.
Mhm.
So I mean, to do that, you can kind of fake it, but it's kind of like this. I mean, that's not very good. This gets real messy, but let's just say those are the midpoints. So again, you would swing some arcs from each of those, and then you come up and swing some other arcs, and then you would end up connecting them. But just for the sake of everything getting kind of messy here, I'm gonna just switch colors here. So again, you'd like swing an arc, something like that. So you've got this green one's kind of clear. And then I'll do this red one here. This red one kind of looks like that. And then I'll switch to blue for the other one. So we swing an arc, swing an arc, swing an arc, swing an arc, and then you connect them here. So it looks like it's right, kind of actually down there on the bottom. So the idea is that they all meet at 90 degrees angles with the side.
Mhm.
Come on, sorry, a little technology issue here. Let me know when you get all that down and we can move on to the next one.
Oh, we can move on.
Okay. All right, so number 6, we are going to do the same thing. We're going to find the 3 midpoints. So we'll just do them one at a time here. So I'll do this. I guess this one's first, right there, kind of the midpoint. So you swing an arc, and then just like we did the others, you swing an arc, and there's some sort of a line that goes through like that. And then I'll go to the one on the bottom here. So there's roughly the midpoint, roughly. Swing an arc, and then to come down here a little bit, you end up something like this. So you get a line, kind of looks like that. And then the last one, again, roughly there's the midpoint. Swing an arc, get another arc, and they actually should all kind of go through that big spot there, but they all meet at 90 degree angles. You could probably get away with just showing the lines. I don't know how, I don't know how, so instructors have a real hard time grading these because there's a lot of work to be done to check it.
Yeah.
So just do the best you can. And 7 and 8 are exactly the same. Wow. Okay. Let me know when I can move on to 7.
You can move on.
All right. I wonder if we had done this last Wednesday, if I would have had more enthusiasm. This is not a very interesting topic, but
Yeah.
it must be done. So bottom there, let's call that the midpoint.
The
You,
last two are the same.
yeah, they're just like this one. They're
Oh.
just like, yeah, if you want to,
So can we just do 2.6 constructing in centers?
yes. So anyways, this looks like, yes. So you said 2.6,
Yeah.
the bisector of each angle. Yeah, we actually should have done this one first. All right. Yeah, let me, I just need to rotate the picture. Rotate left. There it is. Okay. All right, so here we go. The way that you do this is you go right to the vertex there and you swing an arc such that it goes through both of the other two. And then you go to each of those points where it hits and you swing an arc different size than the one you just did. And you end up connecting the dots there like that. And the idea is that this angle is congruent to this angle. This is one of the early ones that they show you, and I think it's kind of cool to see this.
Okay. Okay. Number 2.
Number 2, let's get this going. Here we go. Yeah, so same thing here. You start with the vertex point and you swing an arc that goes through both of the sides there. And you create an intersection point. And then you increase the size of your protractor compass thing and you swing another arc. And then from each of them, and you get a point of intersection there. And then that connects with the vertex. And these angles are congruent.
Okay. Are these all the same as the paper we just did?
No, they're oh, the angle bisector. No, I mean, for 3, you got to do 3 angle bisectors. So I can look, I'll show you 3 or 4. I'll show you 4. So you just end up doing the same thing we did for each of these. And you end up getting, you know, and like, so if you were just kind of trying to shortcut this, you're just trying to bisect the angles, something like that. Although they do all go through the same point. So this is not a good enough drawing. So let's not do that. Let me see if I can freehand it a little better. So let's see here, something like that. Like that. And then that third one has to go through the other point there, like that, without the curve. That would probably be sufficient for for these. And you would do the same thing on 3. So 5, 6, 7, and 8 are the same, but we can quickly do 8 and 9, or I guess 9 or 10.
Yeah.
So for 9, it's the same thing. You're supposed to find those 3 bisectors,
Hmm.
angle bisectors, and then that gives you the radius, or that gives you the center of a circle. So you go out to the shortest side, and you draw a circle that just barely touches all 3 sides from there. And for 10, it would be very similar here. So let me get 10 up here. So there's your center of your circle. And again, you just kind of create a circle like that. Again, we're taking a lot of like liberties here to do this, but I understand the goal is probably just to get through it.
Yeah. Okay.
All right, so that's probably a good place for us to stop for tonight. I know we got a lesson on Wednesday, so we can either finish this up or move on to something else. If you need help in Delta math, we can also do that. Whatever you
Okay.
want. Thanks for letting me help you, Jasmine. Hope you have a great night, and I'll see you in a couple of days.
Okay.
Bye now.